Hello, my name is Casey Shibler, and I'm doing a reassessment on the Faraday's Law standard. The following problem states that in the figure, a very small circular metal ring of R being 0.5 centimeters and the resistance given is at the center of a large metal ring with a R of 50 centimeters. The two rings lie in the same plane with time when it's 3 seconds, the large ring carries a clockwise current of 3 amps, and when time equals 3.2 seconds, the large ring carries a counterclockwise current of 5 amps. First, it asks what is the magnitude of the EMF in the small ring during this time. So, what I've done, and I have written down all my values. I have R small, X being the resistance, R large, I1, T1, I2, T2. So I tried calculating the magnetic field or getting an equation for the magnetic field of both the large ring and the small ring, since they're both going to have to play a part in this, considering the small ring's affected by the current in the large ring. So I have the B loop, which is my small ring, mu naught I over 2 pi little r. Then I have my large, which is my B ring, mu naught I over 2 pi big R. As you can see, I have to find the magnitude of the EMF. So I know EMF is equal to the change in magnetic flux over the change in time. I know the magnetic flux is going to be equal to the B of the ring, the large ring, times the area, or B perpendicular to the area. So what I do is I go and I plug that into my dB, or my change in magnetic flux, to get that equal to the change in my flux over time. I can pull out my area because my area is not going to change, so that's a constant. So I then have to integrate or derive B ring over change in time. So I go ahead and plug in my B, which is up here, mu naught I over 2R, and then I bring it down and I go ahead and pull out again area mu naught over 2R because those are constant. So then I just have to find the change in current over the change in time, which they've actually given me those values. So then I just plug in my values and I get my magnitude of EMF, which is 1.02 times 10 to the negative 9 volts. For part B, it asks what is the magnitude and direction of the average current in the small ring. So the current is probably going to be counterclockwise. That's what I am guessing, is that the current's going to be counterclockwise due to the current in the large ring. So I have my current equals EMF over R. So it's asked me to find the magnitude of the current right now. So I already solved for my EMF, so I just do EMF divided by the R value that they gave me, which is 5 ohms. And so I get 2.04 times 10 to the negative 10 amps. For part C, it says what is the average electric field in the small ring during this time, and give both the magnitude and direction of the electric field. Well, the direction of the electric field's pretty simple because it's going to go in the same direction as the current. So, as I actually wrote here. And then from chapter 21, it says, we kind of go over the relationship between current, electric field, and electric flux. And I know that electric flux is equal to E times A. So I can actually do the current that's equal to epsilon naught times the electric flux over change in time, or the change in the electric flux over change in time. So I get my epsilon naught times change in electric flux, which is E times A over delta T. This gives me an E that I can work with to find the magnitude. I don't really know of any other way to do it. So I have E is equal to I times delta T over epsilon naught times A, which is my area. We already got I back here. So I already have my I value. For my delta T, that's my 3.2 seconds minus 3. And then for my epsilon naught, that's a constant. And then I have pi r squared, which is the radius of the small ring, since we're looking for the electric field in the small ring during that time interval. So I have E is equal to all of this equals 58,698.5 newtons per coulomb. I have my current, and then I have my electric field going in the same direction as the current, which is a result of having that larger ring around my small ring. Thank you very much.